Hey, apply pre-cal. Leave some space for your title on this one. Let's leave a blank space for that. Because I want to work through an example first. If I was to give this to you in grade 9 or at the start of this course, you could probably solve it. It's a bedmass problem. If you don't remember, bedmass is the order of operations. You can do your brackets, your exponents, your division, multiplication, and then your addition and subtraction at the very end. So when you're looking through this problem, you're like, oh, okay, well, I got some brackets over here. I'm going to do that first. Then you have to find exponents, and you're like, okay, well, there's an exponent here. And then you got to find some multiplication and some division. I don't really see any of that. And there's a bunch of addition and subtraction. So you could work through this problem, except there's one issue. The square root has never shown up in any of your bedmass problems before. When do we do square roots? And that's what today's topic is. You probably read the title of the video and figured it out. But it's fractional exponents. A root or a radical is just an exponent, but it's a fraction of an exponent. So whenever you have the radical, it's always going to be in this form where you've got a number, which is representing the root itself on the outside, and then you may or may not have an exponent on the inside of your radical. If you don't have an exponent, remember it just means it's to the exponent of 1. And if you don't have a number on the outside of your root, you know it's a square root. Basically, whenever we're converting one of our radicals into a fractional exponent, whatever exponent is on the inside of that root, that ends up becoming the top of the fraction. And whatever root you have, whatever number is representing the root, ends up becoming the bottom of the fraction. We can look at it with some numbers as well, which might be a little bit easier to understand. So I've got 3 examples here. I've got the cube root of 5. I've got the square root of 12 cubed, and I've got the 4th root of 2 cubed. What are those solutions going to look like? Well, they're going to look like this. In the first case here, I don't have an exponent inside of my radical, which means that my exponent is a 1. 5 to the exponent 1 is just 5. So that's the top of my fraction. Bottom of my fraction, the denominator comes from the root itself. So it's 5 to the 3rd. In this case here with the 12 cubed, which is inside of a square root, well, the square means that my denominator is a 2, and the 3 from the cube ends up going on top of my fraction. So this is 12 and 3/2, or 12 to the 3/2. My last example is the 4th root of 2 cubed. So I still get 2 cubed in a sense, but it's now in a fraction. The bottom of my fraction, the denominator comes from the 4th root over here, which gives me 2 to the 3/4. And with the final example, we can actually see why, using fractional exponents, why roots are the opposite of powers. For instance, if I have the square root of 8 squared, well, my fraction becomes 8 to the 2 over 2. Well, 2 over 2 is just 1. So I just have 8 to the 1, and 8 to the 1 is just 8. So you can see how my square root and my power canceled out. That's why I'm left with just 8. All right, and then I'm gonna step away and show you something that looks super annoying. I want you to take a step back and not try to soak it all in one go. But the math looks like this for roots and radicals with fractional exponents. What we're dealing with typically is this very first one, when you have a fractional exponent, and the very last one, when we convert it into a root. All the pieces in the middle, where you see all the brackets, those are fair game. You could see something like that, so you need to be aware of how the conversions happen, but we don't typically do that. Now, for those of you going in the pre-calculus route, if you end up going to university and taking calculus, yeah, you need to know every single one of these and recognize all of them. That's where the practice comes from. This is the first time you're seeing this, so you're not going to be able to recognize all these forms just like that. But with some practice, you should be able to start to get familiar with them. Again, I don't expect you to master this, in a week, So spend some time on working with fractional exponents. There's a good amount of work to practice. And if you have any questions, as always, let me know. We'll take things from where we're at.